Okay, hi guys. This is an examples video of the basics of linear equations. So I actually have 8 examples in this video. Here are the first 4, and you can see they're just kind of getting in different levels of complexity, and then here are the next 4, so you can pause and read them over if you want. So I'm just going to get right into it. Just a reminder, I do have free guided notes available at divideandconquermath.com. So starting here with A. So the thing to remember with this is that you always want to get the x's kind of isolated first. So to do that, I'm going to go ahead and add the 5 to each side. So I've got 3x equals 12. And then this is 3 times x. So to get rid of the 3, then you're just going to divide by 3. See, x equals 4. Okay, so moving on to B. Okay, so for this one, so to get the x by itself, so notice it's just switched its position. So to get it by itself, first I'm going to subtract off the 6. So I've got negative 2x equals 0. And then I'll divide each side by negative 2 because it says negative 2x, but it means negative 2 times x. So to get rid of that, you divide both sides by negative 2. Now sometimes this throws people off. It's totally fine to have a 0 in the top. That just makes the whole thing equal to 0. And remember, if you're ever unsure if this is the right answer, or, some people look at this and think, oh, is this supposed to be undefined, or is it supposed to be one of the weird situations? You can always double check. So if I just plug 0 into this, I can see right away that this is just, this does indeed equal 6. Okay, so moving on to C. So now in this case, I've got x's on each side and numbers on each side. So you just want to get all the x's on one side and all the numbers on the other. And it doesn't matter which way you want to go with this. It'll still work out to be the same answer. So I'm just going to bring this 2 over to this side. So I like to start with the x's. You could start with the numbers. That's totally fine. I just, by habit, tend to do the x's first. And then this 7 I got to get rid of. So I'll go ahead and I'll subtract off the 7 from each side. So now I'm left with 2x equals negative 16, and then I can divide both sides by 2, and I've got x equals negative 8. There's my solution. Okay, so for D, so now notice with this one, this is a little bit trickier in that you have actually multiple x's and numbers on each side. So when this happens, what you're going to want to do is you're going to want to first collect your like terms. So I've got 3, make sure you notice this is a minus 7, so 3 minus 7 is negative 4. And then negative 4x plus 2x, that's minus 2x. And then I've got 4 minus 8, that's negative 4. And then negative 6x plus 4x, so that's negative 2x. Now, you might actually already see what the answer is at this point, but I will go forward with the problem. So let's say that I want to just go ahead and add the 2 x's to each side. So I get negative 4 equals negative 4. So what is the interpretation here? So this is a true statement. So when you have a true statement and your x's drop out like they did here, that means that you have infinite solutions. And sometimes the notation for that, the infinite solutions, the notation for that can look like this, negative infinity to infinity. Okay, now one thing I just want to point out. Notice in this step, both sides were the same. That's basically what you're looking for. So there's a lot of different ways that this answer could have presented itself. You could have also had, let's see, I'll mark that off to the side. You could have ended up with like 2x equals 2x or 0 equals 0. But the point here is that both sides were equal to one another. So once you have that, the interpretation is what matters here. It's not actually the numbers in this case. Normally, it's the one solution that you care about, but in these, it's not so important. Okay, so here for E, so I've got a couple things I can do. So here on this side, I can go ahead and add my like terms. So this is going to be 10x plus 7. And then here, this is going to be 7 minus 14x. Okay, so now I'm going to bring all my x's to one side. So I will add 14x to each side. So now I get 24x plus 7 equals 7. And then I can subtract off the 7x to get 24x equals, oh, sorry, I said 7x, I mean just subtract off the 7. So I get 24x equals 0. And so then once again, so if I divide both sides by 24, so 0 on the top just means that the whole thing's going to equal 0. Okay, so for F here, the only thing you can do to start is you've got to distribute everything. So I'm going to start by distributing. So let's see, I've got 15 minus 6x. Now be careful with this one. This one says minus 6. So negative 6 times positive 3 is going to give me negative 18. And then negative 6 times positive 2x is going to give me positive 12x. And then this will be 5 plus 10x. Okay, so now this is going to be negative 3 plus 6x equals 5 plus 10x. So now I got to get the x's on one side. Now it doesn't matter which side you put the x's on, so I just happen to take them over to this side. I usually like to do the subtraction that will ensure my x's end up negative. It's just force a habit. So for instance, I'm going to subtract this 6x off. So this is minus 6x minus 6x. So this is negative 3 equals 5 plus 4x now. And then I'm going to subtract off the 5. And this is negative 8 equals 4x. So now I have to divide both sides by 2. Or sorry, divide both sides by 4. So I'm going to divide both sides by 4. I'm running out of room here, so I'm just going to write it out like that. So I get x equals negative 2. Okay, so here for g, so it's the same idea. So we have to start by distributing once again. So let's go ahead and do that. So this is going to be 8x minus 4. Again, be careful, this is a negative 2 right here. So this is minus 12 plus 6x equals 6x minus 8. Okay, so if I collect my like terms on the left side, I have 14x minus 16 equals 6x minus 8. So I'll bring all the x's over to one side, so I'll go ahead and subtract off the 6x first, like this. So 14x minus 6x, that's going to give me 8x. And then I got to get the 16 over to the other side. So I'll add the 16 to both sides. So I get 8x now equals positive 8. And if I divide both sides by 8, I will get that x just equals 1. And for our final example, so we've got just a lot going on here now. So first I got to just start by distributing. You can't start collecting like terms with this because by the order of operations, you first got to actually deal with these parentheses and the distribution. So let's start there. So this is going to be 6x minus 15 minus 4x plus 1 equals 4x minus 12 minus 2 plus 6x. Okay, so from here, I'm going to go ahead and collect my like terms. So let's see, that's going to be 2x minus 14 equals 10x minus 14. And one thing I like to do always is, by the way, I usually just double check my signs like before I move on. So just, you know, I've got this negative 2 times this, so that's negative. This times this, that should be positive. So I'm always kind of checking that in the back of my mind. Okay, so now I can go ahead and start. Let's see, I'll bring the 2x over. So I've got negative 14 equals 8x minus 14. And then I can add the 14. So I get 8x equals 0. Divide both sides by 8, I get x equals 0, and I'm good to go. So that'll cover it for this video. So hopefully that was a good amount of examples. Got any questions, feel free to leave me a comment. Otherwise, thanks for watching, guys.